Welcome to chapter 6. We're going to be talking about the formulas of the elements in this section. And in the whole chapter, we're going to be talking about chemical nomenclature. And chemical nomenclature is just maybe a fancy way of talking about the system that's used to name chemicals. And so the key to success in this chapter and in learning chemical nomenclature is to learn the system behind it. Don't try to memorize the names of, over 1,000 compounds. There's not that many, but that we're going to talk about in this class at least. But, don't try to memorize everything in that way. Try to learn the system. It'll help you not only in this class, but if you have to take chemistry classes in the future. And so that's the key, all right? The key to the city, as is shown here, all right? So I don't know who this is. I don't know what city this is a key to. If you let me know, that would be great. But that's the key. Learn the system. Don't try to memorize all the names. And we've already learned about the symbols of 35 elements. And in this chapter, we're going to learn the chemical formulas of those elements. And that's something we actually, like I said, already learned. So really, it should say more in this chapter, we're going to review the chemical formulas of these elements because it's something we already talked about in chapter 2. All right. So review from chapter 2, formulas of the elements. For most elements, the smallest independent particle is a single atom. The formula of a single atom is the elemental symbol. So for example, let's say we had something like, I don't know, iron. Okay, so the smallest independent particle for this is a single atom, so the formula is the elemental symbol. And remember, for iron, this is the element symbol for iron, okay? So that's how we would write it. But 7 elements form diatomic molecules, if you remember that, again, from chapter 2, under normal conditions. And di there means 2. So the smallest particle in a sample of these elements is actually 2 atoms that are chemically attached to each other that forms a diatomic molecule. And remember, in chapter 2, we use this to remember the diatomic molecules. Okay, so the molecules are hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. Okay, so iodine, chlorine, and bromine. And again, they exist as diatomic molecules where there's 2 atoms chemically attached to each other. And from our chapter on chemical bonding, we know, for example, for chlorine, that this is going to look something like this. Right? Where this is the bond between them, this line here. It's the 2 electrons that they're sharing. Okay? And so we can remember these molecules by using this acronym. I don't know actually what you call that off the top of my head. Maybe it's something really simple. It's a way to memorize it. It's kind of early here, but it's have no fear of ice cold beer. So that's hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. Okay, so on the next slide, this is just them listed out again. So the chemical formula of the diatomic molecules is the elemental symbol followed by a subscript 2. Okay, and these are the 7 elements again that occur in nature as diatomic molecules shown here. So this is something that we need to remember. And so when we're writing down the symbols of these elements, as we're going to do here, or the formulas of these elements, I should say, we need to keep that in mind. So why don't you pause the video and go through this quickly on your own. Again, this is kind of review of things we've already learned, but let's just refresh ourselves. Let's see if you understand it and kind of follow along. So write the formulas of the following elements as they should be written in a chemical equation. Okay, so pause the video, go through these really quick, and then we're going to go through them together. Okay, so for elements, let's go through it. So potassium, that's not one of the diatomic elements. So this is just its elemental symbol, which is a K. Fluorine is one of these diatomic elements. So it's going to be F2. Okay, is its formula. Hydrogen also is, so it's going to be H2. Nitrogen also is, So this is going to be N2. And again, I'm just getting this off the periodic table. Calcium is not one of those diatomics. It's going to be capital C, lowercase a. It's his elemental symbol. And copper is Cu. Okay, so again, this is just review of things that we've already learned talking about these diatomic elements. And one thing to keep in mind, though, that we didn't discuss in the last chapter 2, when we talked about this, is that some elements commonly form polyatomic or many atom molecules. However, their natural molecular form varies. You know, some of these compounds might have more, some might have less. So in this class, we'll write their formulas as if they were monotonic one atom species. And this won't affect calculations that we'll do later involving the elements. So what do I mean by this? Well, carbon, for example, can be found as diamond. It could be found in nature as graphite. And each one of these compounds has a different number of carbon atoms. Over here is another type of carbon that's found in soot, a buckyball. I believe that's what's in the bottom of this tube here, where it's kind of a circular carbon sphere, okay? That's different than graphite, that's different than diamond. And you can see each one of these spheres are different atoms of carbon. So you can see there's quite a lot, okay? Same idea with things like phosphorus and sulfur. They're found in many different forms in nature. So we're just gonna represent them, their formulas, like we have already, okay? Carbon is just going to be C with no subscript. It's just its elemental symbol. Same with phosphorus, same with sulfur. But this is just to kind of make you aware that in nature, these compounds exist in many different forms, okay? Polyatomic forms, okay? So again, don't have to worry about it when you're doing your writing down the chemical formulas for these guys. Just treat them as if they are monotonic one atom species. The diatomic molecules are the ones that you have to worry about, okay? So that's it for that section. And then we're gonna move on now to talk about naming compounds of two nonmetals or two types of nonmetals bonded together. So see you in section 6.3.